Can be perfect. So, you know, one day our product owner walked into the team area and then told us that we are changing the strategy of the whole project we are working on. So we are building the data lake for our big international bank called Raiffeisen. And the change in the strategy was so that we are going to deploy our data lake into almost every country. So we're gonna offer this existing environment as a platform. And this, of course, was a bit of a shift, I would say, in our whole environment and how we started to build this thing, right? I guess you all have been there when some new requirement came up, and it sounds easy, but it's really changing the whole game from the basics. And this is exactly what happened to us. Today, I will talk about this journey or this war story we had with this thing. I will show you a couple of things, how we did manage to overcome the difficulties and how we did solve it with the help of HashiCorp tools, mainly going to talk about Terraform anyway. So as you can understand the situation, previously we had like 3 environments. Like we had development environment, we had a test environment, and then we had a production environment. And this needs like a certain way of thinking. This needs that we organize our templates in some way, and then we organize our environment definition files in one way. I will talk about more about that. And yeah, so we changed from basically running a production environment to provide our solution as a platform. And that's what the today meeting is about. Yeah. So how to release our existing infrastructure as a platform, how we did change the Terraform templates, and how we reshaped our development process to serve our new strategy. So the development process, and let me stop here and talk a little bit about this, because I think it's very important to understand that now infrastructure as a code means that people previously being system administrators and great networking guys and so on, they basically from one day to another they find themselves in a software project. I mean, as it's infrastructure as a code, right? Code means that it's a software project. And that's where the story gets interesting for these guys. Let's talk about a little bit how this is supposed to work in an agile, agilist, software development project. It's all starting with the developer, right? This little green guy in the middle is the developer. And he's starting with getting a job, right? Hopefully from a Jira or whatever system. He gets a ticket and he starts to work on this thing, right? Let's not talk about the planning before and how the road map is created and so on. So the development cycle is supposed to start with writing the test case, this test-driven development, right? I mean, test-driven development can be now applied on infrastructure too, which is really a great thing. I mean, this is endless possibilities, really. So you write a test, you execute the test, and the test will fail because there's no implementation behind it, right? And then the next step is that you write an implementation, and this will fulfill your test case, and the test starts to pass. And then you repeat this cycle until your development is basically done. What you see under here is a little graph about how we did this and how we're supposed to do this in Git branching and so on. So that, this was a part of a bigger picture, which I had to a little bit slice up 4 slides, so you will see them. Yeah, so in Git, this should mean, of course, that the first thing the developer is doing is to branch out into a development branch, and then there he's starting to work. If necessary, he can still pull or rebase changes from the master branch. So if other developers finishing their task before him, he can update his branch. This way, the difference between the release branch or master branch and between the development branch is really minor, right? It's only the change I am making. And that's the purpose of this whole exercise with the Git thinking and basing and so on. Then what comes in the development cycle, I call is the first testing cycle. The first testing cycle is when the developer is done, and if he has good enough tool sets, he is able to execute the regression test, the test you're using to see if the changes is breaking anything else in the existing system, right? This is basically the collection of your existing test cases. So if the tool set is in place and is good enough, then the developer, before merging the code, can execute this test set on his branch. And that would be the first testing cycle after the test-driven development, right? So the first set of testing which you do in the development cycle is more like unit testing, or in our case, it is infrastructure testing anyway. But let's talk about it a little bit later. So this would be the first testing cycle, of course. If the test execution fails, so we figure out that we're breaking something unintentionally, and luckily we catch it on this testing cycle, then we go back to the development cycle, right? This just goes back here, here, and this goes on until we pass this cycle, right? Now, the next one is that we create a pull request, a review request, basically. And then comes the review cycle in the development process, right? This is very important. Again, we make the review, and then this is the reviewer here, the red guy. He do, review, make comments. If necessary, he makes change requests, basically, right? He tells the developer, hey, I don't like the font color here. This network is too small, whatever. Then we just go back to the previous cycles. The developer goes, changes the thing, re-execute the test sets, and coming back to the pull request. For us, it's kind of important at this point. We prefer not to reject, but comment on these code things until it's perfect and it can be merged. Because this way you see the code review comments in the tool and so on and so on. By the way, we are using Code Build and Code Star from Amazon for this, but you will see that later a little bit. So when the review is done, right? Here you still see what's happening in the Git side, nothing really interesting. When the review is done and we do the merge, then comes the second testing cycle, I call. So this is the point where you merge your changes to the master branch, the release branch, and then automation kicks in. This is where the continuous integration pipeline should kick in, right? This is where we are testing if your change is now introduced in the master is breaking anything in the past. This test set is quite similar or exactly the same what the developer is running in the first cycle, but it's after the merge, right? Again, if it's failing, then the commit should be reverted. In our case, it's a bit different. We don't revert the commit, but there is no new tag created, so we can still fix it and we can go back to the previous release tag. You will see unfortunately not in a live demo, but in pictures, how this is working. So how is the CI pipeline looks like, and I will explain it a bit more in detail. So if everything works and all the test cases passed, then we create a new tag. Now, this is a Docker tag, so you will see that later what is our build process for infrastructure today, and that's what is this all about, right? But I really wanted to show you how this is working. So when the tag is created, then comes the release cycle, which should be, as often as possible too, to keep all the systems out there updated and having the same stuff as you do. I mean, so far, this is not really specific to our story. This is how it works for dev test prod kind of environments. And this is how it will work, or it is how it works for us for the N+1 environment kind of setup. But I think it's really important if you start on a new project to set this process and all the tooling in place. This gives a really good foundation for your team to, continuously improve the code and keep the quality. So in this process, as you see the testing cycles, the quality assurance is built in. As long as you really mature and manage to keep these steps and roles and saying that we don't merge anything without test cases introduced and so on. So that's part of the reviewing process and the cultural thing. So the automated deployment clicks in, and this is the part which we called here the release, but this is the continuous delivery part, right? This is another pipeline in our case, which uses the build tag from the previous steps and then releasing it on the endless number of accounts we have. I will show you the two, only on pictures, unfortunately, but you will see how it's supposed to work with Amazon services and how you can use now everything we made to basically deploy your Terraform infrastructure as a platform for multiple accounts with the delivery pipeline. So, when everything works, automated deployment goes down. You can have even a post-deployment test, pre-deployment test, if you like. And then if everything really, really works, then it's like an epic mic drop and developer is happy, Jira is updated, task is done, right? This is really nothing new. And honestly, the whole thing is really nothing new. I just wanted to show you how it is possible to combine these tools to make a pipeline for delivering, for building, and how to build in the quality assurance. So when it comes to tooling, it is a pretty interesting topic or part. As I told you, the process is kind of well known. If you ask any developer, they know how it's supposed to be done. And when you start with a new project, I truly believe that the first thing to do is to set up this process and all the tools for it. So the tooling, what we did, right? We wanted to have the same tools everywhere. Again, very old principle. In the past, we had lots of issues when you are a programmer and you don't use the same version of libraries, the same version of tools, don't even use the same tools maybe, then you can have really, really nasty issues along the way. So what we did, we said that, okay, we put all our tools and everything into a Docker build. So we have a Docker container, which has all the tools, same versions, same configuration, same everything within one container. Why? Because I can give this container to any of our developers, anybody in the organization. In fact, it doesn't matter if they're running on a Mac and they're running on a PC, they're running on a whatever microcontroller. As long as they can run the container, they will get the same results and the same stuff. But then when we changed in the strategy and we said that we want to release all of these things, we said that, okay, maybe we should add our templates into the container and call the container as the delivery, right? So what we're doing is that we merge the existing tooling container with the templates. So the build process is layered, right? We first build the tools, then we do the templates, and then we put them together to create a new container. And this new container is our delivery. So one data lake release today is one container, which has all the tools, Terraform and everything around that I will show you, to deploy the infrastructure, our solution, right? And this is amazing because if you think about it, we can Docker tag these containers. We can test upgrade passes from one version to another by just deploying the first container and then deploying the second container, right? So this is like a one-shot container. You call a bash script inside, which will run Terraform in it and Terraform, blah, 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 all of those things. But you're going to see most of them in a little bit later in this presentation. So yeah, this is how we do it, right? And the nice thing again about containers, you can keep the container images in the ECR service, which gives you again a little bit more possibilities in Amazon. It means that you can use it in the ECS service. It means that you can use it in code build, which we utilize a lot in our code pipelines. And yeah, the other important thing is that, of course, around Terraform, now we have Docker, and you will see I added other tools there to make our life easier. I wanted to wrap up the whole thing and make it easier for my team to use it. So what would you pick as a programming language in this case, right? I get a lot of feedback from other people. Why is it not Python? It should be Python. No, it shouldn't be Python, as I see, right? The reason is that Bash is super simple to use. Most of us is using a Linux box for the operations. And with Bash, I can just write a script. You can source into your Bash. So I can, change the command line prompt. I can add tab compilation. And honestly, if you write this kind of thing in Python, you either start to interface with strange things like Docker and Terraform and so on, or you're just calling them. But if you're calling them with syscalls, or if you know sysexec, it's terrible. I mean, Python is not meant to use as Bash, and Bash is not a Python. So I just picked Bash, and it's working very well. It's super simple. And it basically gives you a shell kind of experience, right? Because you just source into our tools and it's working. What we did on the side is that we extended a little bit Terraform with the power of open source, I call it here. We added Jinja on the top of the Terraform templates. And then we are using JSON as our configuration language, right? This is kind of important part, that all of these things are using Jinja and JSON. Here you will see why we are using Jinja. So if you don't know Jinja, you can search for it. It's very much used in web development, front ends, and maybe in backends too with Django. It's a very simple templating language. You can write this kind of nice, let's call them tags or whatever they are, into your text file. Then you can run Jinja, and Jinja will calculate or create a result out of your template and your input variables, right? So this is what's happening here. As you can see, in the middle of a Terraform template, I'm able to write now for loop. And this is totally independent from Terraform. Terraform don't know about this, right? Because I will first run Jinja. It will generate a big template, which is harder to read and so on. And then Terraform can execute the things. Of course, you have to understand when we started to do this, there were no, count fields for modules and so on. And this is really giving us a higher level of abstraction where we can, write almost everything and anything. We can have for loops, and, as you will see here, this is how you can use the variables. There's only one kind of important thing. If you do a for loop and you have a resource inside of your loop, you want to name them differently, right? Because the calculated template will otherwise have the same name for every resource. And then your Terraform apply will fail because of that. And this is kind of showing you the example how you can use the variables. And then, let's jump to the environment definitions, like what we are feeding into Jinja and into Terraform. So one thing we wanted to solve with this one is, again, about abstraction, that I want to write a template which is totally independent from my environment. So what we did is that we separated the code from basically the definitions of the variables we're using in the code, right? The code has to be like 100% reusable just by changing the variables. This is, again, a very important pattern we are using, right? So we put everything into JSON files that I already told you. And then in our little scripting environment, we introduced multiple ways to do this, right? Multiple scopes, if you like. So this is how our project directory looks like. Unfortunately, I had to mask out the environment names. So this is where in the environments directory, we have our environment names, and we already have a config file here called global. So every variable you define in the global will be actually global. So it will be passed to every project on every environment. Whatever you do, the global will be there for you. So if you have a Terraform variable, our little script system will inject these variable definitions, variable assignments, basically, into this deployment of yours. And as you will see, so within an environment directory here, we have a couple of more files. We have one called common. And a common is one file which is passed for every so-called project, Terraform templates, you want to apply on this environment. And then we have the Datalake one. This one is basically a pattern where you say project name, Terraform vars.json. So this one will be only fed into the Datalake project. So these are, you will see what is a project for us. It's a template directory with Terraform templates, defining one very well defined subset of our environment, right? Or some part, yeah. And then you have one for the environment definition and one for the provider. Well, the environment definition is passed to everybody just like common, but it's a little bit separated for us because we wanted to have a space where we can say that this is a dev environment, this is a prod environment, this is whatever other variables are there. And then you have the provider configuration. Well, the provider configuration is a bit tricky. This is something we pass to the Terraform init. So this is for the init stage, right? And as we are using S3 as our statefile backend, we have a bucket here. We have a DynamoDB table for the locking. We have encryption enabled, of course. We're a bank. I mean, everything is encrypted 6 times. We have a KMS key ID, region, role. So this is how one configuration file looks like. All the others having the same structure. It's a JSON file. It's like nothing fancy. The fancy thing is about the scopes of these, as you may understand already. Now, I was talking about the project. What is a project for us and what is the project directory, right? So in the templates, we have these project directories. This is an AMI builder kind of template we're checking now. And we have a build config. Because what is a build config for Terraform, right? This is something our script is using to define which files of this directory you want to get into the Docker container. Because we want to pack the whole thing into Docker, but maybe you don't want to put there your test files or whatever. You can have readmes here and so on. Not everything has to go to the Docker file. I mean, generally, it's a good idea to keep the Docker containers small. Our ones are quite big, but it's deploying a whole infrastructure. So there's a couple of things you need to have there. But that's what the build config is doing. And surprise, this is a JSON too. In the JSON, you can just define, for example, the modules, which is pretty important thing, and then template files. And then you can have, again, TF-var files. I mean, this is yet another scope of variables. And this one is basically for those modules where you want to have variables, but you don't want to change them by environments. And that you can put still here if you like. It's always a good idea not to hard code anything. These ones can be changed even, and the scope can be easily shifted out to the higher scope later if you're willing. This is again just some programming, right? As you can see here, we made a new file extension for the Jinja templates. So this is how our script environment knows that this one has to be, this one has to be fed to the Jinja translator first, and then get the final template before calling Terraform apply, right? And then wrap it up. So as I said, we wanted to have it in a script-ish kind of thing. Here you see the example how you can use this now. So you basically source the tool setup script, and it's changing your bash a bit. It's adding new functions, and it's giving you the possibilities, for example, to update the how's it called, this PS1, the command line. And then it gives you possibility for lots of things. A couple of notes about this. When you write a tool like this for your team, there are a couple of basic rules I'm following. One, if you call the tool without any parameters, it should write a very comprehensive help so people with common sense can figure out how to use it. The second thing I really like to do is to add bash completion. So when you say, Terraform space or TF in our case space, and you press tabulator, it gives you a couple of options. And that's something you will see here in the example that, okay, the first thing, I activate the project. So Terraform project activate Datalake. This is basically just updating variables in your bash script so it knows how to call the containers and what kind of parameters to pass to the containers. And then you can do Terraform environment set environments and it's directory, right? And when you pass tabulator here, right, you get all the environments you can pick. And then, that's how you pick them. Unfortunately, again, I have to mask it. And, when you do this Terraform environment set, you set the environment for your script. And this is how you work locally. And the nice thing about this is how the CI/CD is working, and this is how the deployment is working. All of these tools are using exactly the same script, exactly the same process. So everything I do as a developer in my test environment is 100% matching what will happen in the production environment, right? It's really good. It's the same. It's the same tools, the same versions, same everything. This is what DevOps about is, right? That you can really test these things out before you release it into the wild. Now, what you see here is that the build step is basically Terraform project build, and it's calling a lot of things. The first thing is just copy together the files. We have a couple of tools on the top. Look at the picture here is not right. This picture have to be changed. Oh, sorry. And so it's calling a couple of tools. We have Flake 8 and things like that. Unfortunately, I have to change this picture to show you maybe in the live stream. Hopefully you don't see this video anyway. This is just a backup. And after the build is done, you basically get a Docker container, which is our release. But of course, this is not the one we use for release. That one is built by the CI environment. And then let's just show you really fast how it looks like. So this is how it looks like in code pipeline. The CI steps, so nothing really fancy. The first one is getting the source from the code commit service. It's Git basically. So we get the code from Git, then we do a build, we get an image at the end of the build, which we use for testing. And this is 2 tests. One of them is doing a clean deployment to an empty account, and then doing a destroy. So, in order to be able to pass the CI, this deployment Docker container has to be able to deploy to an empty account. When it's deployed to an empty account, it has to pass the tests. So it's using robot framework for testing. We will talk about that a little bit, only a little bit because I'm running out of time. And then the other step is to destroy the whole environment. Meanwhile, on the upgrade path, what we do is to do exactly the same deployment. Before executing the tests, we do another deployment on the top. So we say, take the actual release container and then put the new container on the top. So this way we emulate or simulate, how this will happen, how this will behave when we release the change on our existing accounts. It's amazing, right? So it's doing a Terraform apply, do the new things there, and then the new container comes with the modified templates and doing a Terraform apply again on the top. And this is the kind of thing we use to deploy our platform solution for the whole bank group. Now, when the test is done, we manually say, okay, everything is green in this CI. We kind of propagate or say, lift up this image as a deployment one. So we manually tag them. And this is a really important step to, tag them. And then we have to change a release config, which is again a JSON, and that will kick in the continuous delivery pipeline, which you see here. This is again very simple. It's getting all the tools and the image getting fetched from ECR. So we know exactly which image will be fetched. And then parallelly, we are executing code build jobs from the ECS image, right, to deploy them. And this is the amazing part, if you ask me, that, one data lake from 0 to operational can be deployed in like 20 minutes, maybe 30. But with the help of this system, we can deploy 50 of them parallel. And this 50 is basically a limit coming from the code pipeline. So it can have 50 parallel jobs now. Previously, it was 10, but we only have like 18 on the top. Now you only see here a couple of less, 9 maybe, yeah. That's just because some of the accounts is not being deployed today for maintenance. And then I was already talking about testing. Unfortunately, we don't have too much time for this, but I did, the team did decide to reuse an old Dell framework. I mean, it's not old, but it's older, called Robot Framework. This is basically a very much used in the telco systems. I know Nokia is using it a lot. I think Robot is a spin-off of Nokia, something like that. And then it's very simple to write test cases. So what you see here is basically test cases. You have some settings, and then you have, check RDS encryption, for example. And you see that the Jira ticket here is basically for one bug fix, right? So we had some issue, we fixed it, and then we created a test for that. And this is how it always should be. Every bug fix should come with the, test matching with. So the thing is this is how it looks like. And it's very simple. It's hiding the complexity in the so-called libraries we're using. And the only reason why we can use Robot so easily because the libraries can be written in Python, and in Python we can use Boto3. So for the previous example, checking the encryption, it's super simple. I'm using Boto3 here, accessing the environment, right? And then checking if all the RDS instances have encryption enabled. Super simple, very efficient, and it gives us, the built-in quality assurance. So every time we release something, I can be sure that there are no new RDS instances which is unencrypted, which would be really bad in our case. And that's just how it works. It has a lot of possibilities. It's, I hope this gives you some overview how we did solve this, maybe gives you some idea how you can solve this. And of course, if you have any questions, I'm super happy to answer them. You can find me by email or on this YouTube chat. I try to tag along for a while. And well, there are many ways to find me. I'm not that hidden. So this was Peter from Norcloud / from Raiffeisen Bank, and it was an amazing time to talk to you. I hope that you enjoy I hope that you did enjoy the presentation. And that's exactly 30 minutes. Amazing. I did a great timing job here. I really hope I can repeat it tomorrow. And I have like 5, 4, 3, back to the studio.